It is highly unlikely that the Boeing engineers who designed this iconic heavy bomber could have ever imagined its true destiny. For a long time, this aircraft embodied the military might of the United States and was a true symbol of American air power. You could compare it to how, a century earlier, majestic British ironclads projected the power of the British Empire across the globe. The designers probably never guessed that their creation would serve much longer than its original design life. It would outlive its creators, and most importantly, it would outlast the Soviet threat that dominated the Cold War era. On the other hand, it is entirely possible that Boeing's pragmatic designers were not focused on geopolitics at all. They just wanted to land another massive government contract and meet the exact technical specs laid out by the military. And the goal was ambitious. They needed to create a heavy, second-generation, intercontinental bomber. It was supposed to replace the Convair B-36. This was the first American strategic bomber with intercontinental range. Originally, the B-36 was designed for bombing missions over Nazi Germany. But after World War II ended, it was quickly repurposed. It was now meant for potential nuclear strikes against the Soviet Union. The initial requirements for this new bomber were issued surprisingly early. The document was drafted in January 1946. This happened several months before its predecessor, the B-36, even made its maiden flight in August 1946, a full 2 years before the aircraft went into mass production. The military needed an aircraft that was truly unprecedented for its time. It had to cover a combat radius of 5,000 miles while carrying a 10,000-pound bomb load. The average cruising speed was supposed to be around 300 miles per hour. At an operating altitude of 35,000 feet, the aircraft had to reach speeds of up to 450 miles per hour. Boeing wasted no time getting to work on the design. They won the competition. By June 1946, they were awarded a contract for further development. The decision to choose Boeing made perfect sense. The entire history of this company, founded back in 1916, is inseparably linked to U.S. military aviation. The company built its first military aircraft, the EA Trainer, in 1917. This was done under a contract from the aviation section of the U.S. Army Signal Corps. In the 1920s, Boeing made a name for itself as the main supplier of fighters for the military. They produced aircraft like the MB-3, P-12, and P-26. In the 1930s, the company shifted its focus to heavy bombers. At first, these aircraft were mainly intended for coastal defense and striking naval targets. This was because U.S. policy at the time was focused on isolationism. Americans had no plans to get involved in European wars. They just wanted to focus on defending the mainland and their territories in the Pacific. A major breakthrough came in 1935 when the company created the legendary B-17 Flying Fortress. Almost at the exact same time, the Soviet Union introduced the TB-7 bomber. This was also known as the ANT-42 or PE-8. These two aircraft became the world's first bombers to successfully combine long range with high speed and a heavy bomb load. This allowed them to deliver devastating airstrikes. In 1937, Boeing tried to push the envelope even further with the B-15 experimental heavy bomber. But their true triumph came during World War II. Their B-29 Superfortress forever cemented its place in history. This happened with the atomic bombings of Hiroshima and Nagasaki in August 1945. This aircraft became the absolute pinnacle of the company's achievements in the era of piston-engine-heavy bombers. Interestingly, an exact copy of this bomber was later produced in the Soviet Union under the name Tu-4. It was this massive reverse engineering effort that allowed the Soviet aviation industry to rapidly advance its technological capabilities. As World War II finally drew to a close, the world faced a new and unprecedented threat. Atomic weapons quickly became the ultimate deterrent of the post-war era. But simply having the bomb was only half the battle. Its actual effectiveness depended entirely on the heavy bombers of the day. Until intercontinental ballistic missiles arrived on the scene in the late 1950s, these giant aircraft were the only reliable way to carry a nuclear payload across vast distances. They were the only way to actually strike a target. Given all that, it is no surprise that the two post-war superpowers, the United States and the Soviet Union, poured their resources and top minds into developing new strategic bombers. These bombers needed to be capable of delivering nuclear weapons. The Americans took this mission so seriously that in March 1946 they established the Strategic Air Command. Then, in September 1947, the military took an unprecedented step. The United States Air Force finally separated from the Army. It became a completely independent branch of the armed forces. Interestingly, even during the fiercest fighting of World War II, U.S. military leadership had flat out refused to do this. This was despite years of lobbying from the airmen themselves. Meanwhile, the era of classic piston engine aviation was inevitably coming to an end. The aircraft already in the American inventory, like the famous B-29 and its successors, the B-50 and B-54, simply could not meet the demands of the new era. They lacked the payload capacity to carry massive early nuclear weapons. They also just did not have the range or airspeed required to fly global missions. Enter the Convair B-36, a true flying behemoth. This was the last of the American piston engine giants. With its ability to lift massive payloads and fly enormous distances, it actually fit the bill perfectly for the early years of the atomic age. But by the late 1940s, the design was already hopelessly outdated. Development had actually started way back in 1941. At that time, the United States government was preparing for a worst-case scenario. If Britain fell, America would have to bomb Germany directly from North American soil. And even though this massive aircraft stayed in service all the way until 1958, its speed left a lot to be desired. Even in its most advanced variant, the B-36J, the bomber was still just too slow. This variant featured 4 jet engines alongside its 6 massive radial engines. It simply could not outrun the new swept-wing jet fighters the Soviet Union was already deploying. If you take a look at classified American bomber programs from the late 1940s, the sheer scale and variety of the projects is staggering. Engineers were relentlessly experimenting. They were searching for completely new airframe designs that would dominate the dawn of the jet age. All sorts of radical concepts were popping up on the drawing boards. They were looking at some incredibly bold ideas like the B-53 project, which featured an unusual forward-swept wing. Another was the futuristic B-49, built entirely around a flying wing design. But right alongside these sci-fi concepts, they were also developing more conventional airframes. They were experimenting with entirely new jet engine configurations. Another crucial factor was that highly classified blueprints and documents captured from defeated Germany played a massive role. They helped shape the design of this new generation of American bombers. Thanks to this captured research, American designers were able to wrap their heads around swept-wing technology much faster. The heavyweights of the United States aviation industry were locked in a fierce technological race. These included companies like Boeing, North American, Convair, and Martin. They were all desperately fighting for multi-million-dollar government contracts. With military orders drying up after the war ended, every company was doing whatever it took. They needed to secure their future in the new atomic age. Engineers typically proved out new design concepts on medium bombers. Many of these successfully made it into mass production. But developing an intercontinental giant was far more expensive. Because of this, the engineering teams had to iron out the exact details on the drawing board. The stakes were incredibly high. Any mistake during the design phase could cost millions of dollars. Initially, Boeing envisioned a turboprop-powered aircraft. Over the course of 2 years, their designers studied more than 30 different configurations for the strategic bomber. They constantly experimented with gross weights, wing planforms, and engine placement. Turboprops gave them the range they needed. This was true even if it meant a penalty in speed. It is highly likely that the U.S. military originally drafted their requirements with a mixed propulsion setup in mind. This was much like they had for the B-36 bomber. Early on in development, the engineers leaned toward a conventional straight wing and 6 turboprops. Eventually, though, they pivoted to a swept wing. By the final stages of the turboprop design, the plan was to mount 4 engines with contra-rotating propellers. In 1949, the company also pitched a design for the B-55 medium bomber. This aircraft utilized 4 turboprops and those same contra-rotating propellers. By that time, however, Boeing engineers were already conducting parallel flight tests on a completely different medium bomber, the B-47. That aircraft was seeing great success with a radically different layout. It featured a moderately swept, long-span wing with turbojets slung underneath in external pods. On top of that, U.S. Air Force leadership started paying close attention to the recommendations of a prominent German designer named Waldemar Voigt. After World War II, he became an advisor for the bomber branch of the USAF. Voigt advocated heavily for turbojets. These promised significantly higher speeds for the new bomber. Interestingly enough, the military had another prominent German specialist consulting for them. This was an aerodynamicist named Bernhard Goethert. He later played a crucial role in refining the wing aerodynamics for the upcoming B-52. Ultimately, Boeing decided to scale up that highly successful B-47 layout for their new strategic giant. They had to take a slight hit in overall range, but in return they gained a massive advantage in speed. Interestingly, a Soviet engineering team led by Vladimir Myasishchev made the exact same choice. They decided to go with turbojets when designing their 3M bomber. At the same time, another Soviet design bureau headed by Andrei Tupolev made a different choice. They decided to stick with highly fuel-efficient turboprops and contra-rotating propellers for their Tu-95 Bear. In October 1948, Boeing finalized their preliminary bomber design. The blueprint called for 8 JT-3 turbojet engines. These later received the military designation J-57. The aircraft boasted some impressive specs for its time. It had a maximum takeoff weight of around 330,000 pounds. It also carried a combat payload of 10,000 pounds. The combat radius was over 3,060 miles, and it reached a top speed of 565 miles per hour. By March 1949, the Air Force awarded the company a new contract to build 2 experimental prototypes. Work on the program rapidly accelerated. Funding surged after the Korean War broke out in the summer of 1950. The Cold War was heating up, and America desperately needed a new strategic deterrent. To extend the range even further, by 1951, right in the middle of the design phase, the takeoff weight of the aircraft was pushed to a massive 390,000 pounds. Construction of the first experimental XB-52 took place under strict secrecy. It was completed on November 29, 1951. However, due to last-minute structural changes, the second experimental prototype, the YB-52, actually took to the skies first. This historic test flight took place on April 15, 1952. The first XB-52 did not begin its own flight test program until the fall. It made its maiden flight on October 2, 1952. Throughout the bomber's development, engineers spent around 6,500 hours in the wind tunnel. They carefully refined every contour of the airframe. The United States Air Force wanted to hedge its bets, though, just in case the B-52 project ran into unforeseen issues. Back in March 1951, they contracted Convair to develop a backup strategic bomber, the YB-60. Conceptually, it looked a lot like its rival. It featured a similar swept wing configuration and 8 turbojet engines mounted on underwing pylons. However, it retained the massive fuselage of the older B-36 bomber. It also featured a significantly thicker wing. The experimental YB-60 began flight testing in April 1952. But the B-52 program was progressing so smoothly that the Air Force quickly canceled the YB-60 backup program. In fact, the decision to put the B-52 into full-scale production was made before the first experimental prototype even completed its maiden flight. The story of this aviation legend truly began on August 5, 1954. This was when the first of 3 pre-production B-52A aircraft took to the skies. Less than a year later, on June 29, 1955, these giants started entering active service. The first B-52B was delivered to a training unit of the Strategic Air Command. Exactly 1 year after that, in June 1956, the 1st Combat Squadron received their brand new B-52C bombers. Production of these bombers across multiple variants ran all the way up to 1963. During that time, the airframes underwent extensive modernization. In the second half of the 1950s, the B-52 completely replaced the aging B-36 fleet. The most incredible part is that even today, after all these decades, the B-52 remains the backbone of the United States Air Force's strategic bomber fleet. Beyond their traditional combat roles, modified B-52s also flew some highly unusual missions. They served as motherships for experimental lifting bodies like the HL-10, M2F3, and X-24. These eventually paved the way for the space shuttle. From the mid-1960s right up until 1973, these bombers were used to launch the unique D-21 unmanned reconnaissance drones. The B-52 also provided the air launch platform for the Pegasus winged rocket. This rocket made its first flight on April 5, 1990. On top of that, they spent years serving as flying testbeds. They evaluated massive engines for giant passenger airliners like the Boeing 747 and military transports like the C-5 Galaxy. The B-52 dropped its first hydrogen bomb on May 21, 1956. Over the next few years, the bomber stunned the world with a series of record-breaking flights that proved its incredible capabilities. In November 1956, crews flew nonstop around North America and directly over the North Pole. They covered 16,777 miles. Then, on January 18, 1957, 3 B-52s flew nonstop around the globe. They covered 24,699 miles in 45 hours and 19 minutes. They maintained an average speed of about 530 miles per hour. But it did not stop there. On January 11, 1962, the aircraft set an unrefueled distance record. It flew 12,532 miles in 22 hours and 9 minutes. For years, during the tensest periods of the Cold War, a portion of the B-52 fleet stood on ground alert around the clock. They were fully fueled, loaded with nuclear weapons, and ready to launch at a moment's notice. In the 60s, Strategic Air Command took it a step further. For years, around a dozen B-52s flew continuous airborne alert patrols. To ensure a surprise first strike could not wipe out the fleet on the ground, the bombers were heavily dispersed by the fall of 1963. 42 squadrons were scattered across at least 36 different air bases. Eventually, global tensions eased, and by 1988, the number of bases for these heavy bombers had dropped to 12. By that point, the fleet had racked up a massive 6.6 million flight hours. However, 71 aircraft had been lost to various accidents and mishaps. By the early 90s, 40 strategic B-52 and B-1 bombers remained on constant alert. But the world was changing. In September 1991, the Soviet Union collapsed, leading to a radical shift in the geopolitical landscape. Following these events, President George H.W. Bush officially stood the bombers down from nuclear alert. Originally, the B-52 was designed strictly as a high-altitude bomber to drop nuclear gravity bombs. Given the massive destructive yield of those weapons, pinpoint accuracy was not considered critical. Still, much like Soviet strategic bombers of the era, such as the 3M or the Tu-95, the B-52 was equipped with an optical bomb sight. This was to ensure they hit their intended targets and to help minimize collateral damage to civilian and non-military infrastructure. However, in the 60s, during the war in Southeast Asia, the strategic B-52 was repurposed for tactical missions. It began carrying massive payloads of conventional bombs. The United States utilized the bombers for devastating carpet bombing campaigns. This tactic sparked a massive wave of outrage and sharp criticism from the international community. Interestingly, on later variants like the B-52G and B-52H, the outdated optical sights were phased out entirely. Instead, bomb drops were carried out exclusively using data from advanced navigation and radar systems. As a result, even during the Persian Gulf War in 1991, the primary mission for these heavy bombers remained massive area bombing. The B-52 flew a third higher and cruised nearly twice as fast as the older piston-engine B-29. These impressive specs seriously boosted the survivability of the aircraft during combat missions. Back in the 50s, United States Air Force brass was highly confident in the success of high-altitude tactics for the nuclear-armed B-52. This confidence was strongly fueled by the successful flights of American high-altitude reconnaissance aircraft. But that sense of invulnerability came to a sudden end on May 1, 1960. A U-2 reconnaissance plane piloted by American Francis Gary Powers was shot down over Sverdlovsk. The aircraft was destroyed by the very first missile fired by a Soviet SAM crew commanded by Major Mikhail Voronin. Later, on October 27, 1962, at the height of the Cuban Missile Crisis, Another U-2 was shot down over Cuba. The lesson was painful. In both cases, the Soviet S-75 surface-to-air missile system did the job. However, according to some reports, the true baptism of fire for the system happened a bit earlier, on October 7, 1959. Evidence suggests that on that day, near Beijing, a Taiwanese RB-57D high-altitude reconnaissance aircraft was destroyed. It was hit by a volley of 3 missiles from a Soviet-made S-75. It was flying at a massive altitude of around 67,500 feet. Even though a Chinese crew fired the missiles, the equipment was Soviet. Furthermore, the personnel had been extensively trained by Soviet engineers. Another notable incident took place on November 16, 1959. Near Volgograd, an American reconnaissance balloon was shot down by that very same S-75 system. It was flying at an incredible altitude of over 91,800 feet. When it entered service in the fall of 1957, the S-75 was capable of destroying practically any airborne target in the world. The engagement range of early versions was about 21 miles. This grew to 26 miles after modernization. Its altitude capabilities were just as impressive. It was able to hit targets anywhere from 9,800 up to 72,000 feet. Eventually, this engagement envelope was expanded. It covered everything from an ultra-low 1,300 feet all the way up to 98,400 feet. At the same time, the system could intercept targets flying at speeds of over Mach 2. To protect their B-52 bombers penetrating air defenses at high altitudes, American engineers resorted to a few clever tricks. They equipped the aircraft with ADM-20 Quail decoy missiles. They also added AGM-28 Hound Dog cruise missiles to the arsenal. This payload was designed to suppress enemy air defenses. This allowed the bombers to drop their nuclear weapons on strategic targets undisturbed. An alternative tactic involved destroying heavily defended enemy bases from a standoff distance. This was well outside the lethal engagement zone of Soviet surface-to-air missiles. However, the unexpectedly high effectiveness of the S-75 against high-altitude targets forced United States military leadership to completely rethink their strategy in the early 60s. They came to an obvious conclusion. The only way a B-52 could slip past Soviet radars was to drastically reduce the distance at which it could be detected. If air defense crews spotted the aircraft too late, they simply would not have enough time. They could not launch surface-to-air missiles or scramble interceptors. The simplest and most effective way to stay hidden was to drop down to extremely low altitudes. This meant flying right on the deck at around 500 feet above ground level. But to pull off a flight profile like that, the massive bomber needed some serious upgrades. Engineers updated the avionics. They also made around 120 structural modifications. This was done to strengthen the airframe against the increased aerodynamic stress. For example, in the 1970s, under a special program called Pacer Plank, taxpayers spent $219 million. Under this program, 80 B-52D bombers had their wings completely replaced. However, flying at low altitude came with a price. Because the air is denser near the ground, the engines burn significantly more fuel. This drastically reduced the operational range of the aircraft. For instance, the B-52H could previously fly 10,000 nautical miles without a single aerial refueling. But those numbers plummeted after switching to the new tactics. Now, with a low-level leg of 2,765 nautical miles, the aircraft could only cover a total of 7,270 nautical miles, and even that required mandatory in-flight refueling. But even with its reinforced structure, the legendary B-52 is by no means a low-level aircraft. Due to its massive wingspan and relatively flexible airframe, the jet reacts sharply and violently to wind gusts, and this is despite having a pretty high wing loading of over 102 pounds per square foot. This happens even with the gross weight of the bomber hitting nearly 420,000 pounds. Picture this. Even in moderate turbulence, this giant cruises at around 375 miles per hour. It flies at an altitude of just under 1,000 feet. The flight crew can experience brutal forces. These range from +4 to -2 Gs simply from hitting rough air. That is incredibly exhausting for the crew and highly dangerous for the airframe itself. Because of this, designers impose strict limitations for low-level flying in turbulent conditions. Depending on how badly the bomber is getting knocked around, its operating weight has to stay strictly between 250,000 and 420,000 pounds. Also, its indicated airspeed cannot exceed 310 miles per hour. In calm weather, American crews do practice extreme low-level flying. They drop down to as low as 400 feet above ground level. However, to preserve the service life of these massive bombers and prevent premature wear and tear on the airframe, those training sorties are immediately canceled. This happens if even moderate turbulence is forecast along the route. In practice, though, during actual combat operations, the B-52 was always used for its classic primary purpose. It was strictly for large-scale, high-altitude bombing. As for the avionics and weapon systems of these strategic giants, they have been constantly updated. They have also been upgraded and refined throughout their entire long service life.